Hello students, I am again here with my new video. As some students asked me that how bleaching powder acts as oxidizing agent. When we did redox reaction, I told you that oxidizing agents are those species which provide oxygen for oxidation. So here the CaOCl2 or the bleaching powder also have tendency to provide nascent oxygen, but indirectly. How? As CaOCl2, which is the bleaching powder we have done, when reacts with the atmospheric carbon dioxide, if it is exposed open in the atmosphere, CO2 is there, so it reacts with that CO2 and forms CaCO3 and evolves out chlorine gas automatically on its own. Cl2 gas evolves out. As the Cl2 reacts with the moisture, water, it forms HCl and nascent oxygen is evolving out. So in this way, this bleaching powder provides nascent word I am using. Nascent meaning single oxygen. NaSCENT. Single oxygen. So this bleaching powder acts like oxidizing agent. Here I have written, thus bleaching powder acts as oxidizing agent. Whenever you go to water park like Crescent or Fun City, in the swimming pool, lots of bleaching powder is added. And that bleaching powder is continuously evolving out Cl2 from it to kill the germs present in the water. And when that Cl2 reacts with water, nascent oxygen is produced. And due to that, whenever you come back from water parks, your skin becomes tan. Your skin is getting oxidized. That's why tanning takes place. Okay, students. So thus bleaching powder acts as oxidizing agent. Is it clear now? Now we are proceeding to the next important chemical compound, and that is washing soda. We have done different important compound, students, and now we are proceeding towards another one, and that is washing soda, and formula of it is Na2CO3.10H2O. What is this 10H2O? In the 9th class also, while calculating out molecular masses of salts or the compounds, we took this type of species also, where H2O is written after writing dot here. So this H2O, this type of H2O, if present, that is called water of crystallization. Water of crystallization. So, how many water of crystallization are present in washing soda? 10. So, washing soda is a common name. What is its chemical name then? I am again and again telling you that you have to do common name as well as the chemical name. So, chemical name is sodium carbonate. 10 is deca. 10 के लिए हम लोग क्या word use करते हैं? Deca. Like 5 के लिए हम penta, 6 hexa, hepta, octa, nona, and 10 is deca. So sodium carbonate decahydrate. Okay, hydrate word is for water. Now how it is prepared? The method used for preparing washing soda is Solvay's method. Solvay process is used for the preparation of washing soda. How it is prepared by this method? Preparation is done by using baking soda, students. Baking soda we did in the previous video, students, NaHCO3. As you are knowing the uses also of baking soda, students, it is used for relieving acidity, it acts as antacid, it acts as fire extinguisher, and nowadays as for the disinfectant of coronavirus, we are putting our eatable like vegetables, fruits in the baking soda So to sterilize them, so to remove, to prevent the entry of different viruses. So this baking soda, that is NaHCO3, is when heated, it gives out Na2CO3. This H is sodium hydrogen carbonate hai ye. H eliminates in the form of H2O. Twice molecule I have taken. H2O and one CO2 molecule is also eliminating out when this baking soda is heated. This Na2CO3 is now recrystallized. Recrystallization is done of Na2CO3 with water. Water here, 10 water molecule I have taken. So here Na2CO3.10H2O, which we are calling as water of crystallization. How to define this water of crystallization? Here I have written, students, fixed number of water molecules present in a formula unit. Fixed number of water molecule present in a formula unit is called what? Water of crystallization. Is it okay, students? Water of crystallization. Clear? So this is how, by the Solvay's method, this washing soda is prepared. Now we are proceeding towards its properties. What are the properties of washing soda? When washing soda is exposed to air, as washing soda is having water of crystallization in it, that water present is in the form of crystal. It is not present in the form of liquid there. So, as this washing soda is exposed to air, it simultaneously start losing its water of crystallization. अपने आप जो water molecules as a crystal present है, they start evaporating out and they form, like here Na2CO3.10H2O. We are not heating it. As it is exposed to air, open atmosphere, these water molecules start evaporating and it forms Na2CO3.1H2O plus 9H2O are eliminating out by their own. This process of evaporation of water molecule, water of crystallization, is called efflorescence. Important phenomena, students. Efflorescence. When any compound which have water of crystallization is exposed to air, it start evaporating out that water of crystallization by its own. This process is called efflorescence. अपने आप हो रहा है. And as you are observing that one water molecule is still present, and if now this hydrated molecule, if single molecule of H2O is there, single, double, thrice, thus kitne bhi ho H2O as a crystallization, it is called what? Hydrated molecule. So here, since this one H2O is present, this is hydrated. This is also hydrated. मैंने आपको बताया कि एक भी water of crystallization है तो उस molecule को हम क्या बोलते हैं? Hydrated salt. So this Na2CO3 is still hydrated. After the elimination of 9H2O, still it is hydrated. Now to remove this 1H2O, it is heated now. Na2CO3.1H2O when heated now, it gives Na2CO3 and one water molecule is also separating out. Okay. Now this is anhydrous salt. Here we can call it as anhydrous. Water is not present there now. It is anhydrous. And name of this anhydrous Na2CO3 is soda ash. It is soda ash, Na2CO3, and H2O is separating out. So this is one of the property that firstly it is showing efflorescence. By its own it is eliminating out H2O. Then if further heated, that one molecule of water also get evaporated and we are getting soda ash. And the molecule is called anhydrous molecule because it is not having water in it. Okay. Now the next property we are taking is it is basic in nature. How can we say that this washing soda is basic in nature? If we want to test the nature of any substance, we dissolve it in water. As this Na2CO3 is dissolved in water, it forms NaOH. Here I have written balanced equation, you students, you can see to it. NaOH and H2CO3. NaOH, if you remember students, is a strong base, and H2CO3, which we call as carbonic acid. If you don't know the name, students, you should write down in your classwork copy. Carbonic acid. Okay, carbonic acid, and carbonic acid is weak acid. But NaOH, sodium hydroxide, is a strong base. And if strong base and weak acid is there, the salt obtained will be basic. So, sodium carbonate or washing soda is basic in nature. If it is basic, students, and if it reacts with acid, what will happen? Base, when react with acid, what will happen? Neutralization reaction will take place. So here, Na2CO3 if treated with H2SO4, if treated with HCl, here I am asking you to write the reaction with Na2CO3 with HCl and write the product by your own, students. Clear? So here I am telling you that when this basic salt is reacting with acid, neutralization reaction will take place, formation of salt and water. Salt is Na2SO4, H2O and CO2. Here one more thing I am reminding you, students, and we did that with one of the important topic, like acid when reacts with metal carbonate. If you remember, students, acid when react with metal carbonate or with metal bicarbonate, brisk effervescence of CO2 evolves out. So you can remember the things by relating it with previous chapter also, students. So Na2CO3 plus sulfuric acid H2SO4, what we are getting? Na2SO4, water and CO2. Similarly, Na2CO3 when react with HCl, salt NaCl will be obtained, H2O will be obtained, and here also you will get brisk effervescence of CO2. You complete that reaction and balance it also, students. Next topic is now the uses of washing soda. We are doing washing soda, students. First use here is in, as the name is washing soda, that means it is used in laundries for washing clothes. Laundries में use होता है for washing clothes. I want to remind you, students, that bases are the main constituents of soaps and detergents. So it is also a basic salt. It is washing soda. It is used in soaps and detergents especially. So it is used in laundries for washing clothes. Next is for the removal of permanent hardness of water. I think many of you are not knowing that what is hardness of water. Sometimes some dissolved salts of calcium and magnesium are present in water, which makes the water hard. Water hard meaning, students, that water do not give lather with soap readily. If you are dissolving soap in water, you will not get froth. झाग नहीं मिलता जल्दी, मतलब साबुन पानी में घुल नहीं रहा है. So if you are not getting lather readily of soap in water, that water is considered as hard water. Like, students, sometimes the utensils in which you are storing water develop some scaling in it. कुछ depositions दिखाई पड़ते हैं. that depositions are of calcium and magnesium salts only, and that water is called hard water. A very simple if concept if we are taking of hard water is if water do not give lather with soap readily. Lather meaning jhag, foam. Rather readily jhag agar nahi mil raha hai, then what that water sample is called hard water. And if you are getting lather readily, that is soft water. So if a water is hard water, then this washing soda is used for the removal of that salts which cause hardness in water. And what are that salts? Salts of calcium and मैग्नीशियम और कैल्शियम के सॉल्ट्स होते हैं स्टूडेंट्स, जो वाटर को क्या बना देते हैं, हार्ड बनाते हैं. ओके, नाउ द नेक्स्ट यूज इज lab reagent. In the lab also this Na2CO3 is used for different chemical tests. And the last use that I am telling you, it is having many uses, but some uses I am telling you. It is used for making glass. In the glass industry, this washing soda is used in making soap. I have told you previously also that it is basic in nature. It is used in soap, in laundries. And as we did, students, that caustic soda was what? NaOH. So this washing soda is also used for making caustic soda, as we did in the hydrolysis reaction, students, that Na2CO3 when dissolved in water, it is giving NaOH, and NaOH is what? Caustic soda. So this washing soda is used in different fields, laundries for washing, for the removal of permanent hardness, as a lab reagent, or for the manufacture of glass, soap, or the caustic soda. Okay, students. Now here I am telling you, if the salt contain water of crystallization is really dry, yes, it is dry. We are proving this. That means I am asking you, students, that if water molecules are present in the salt, can it really be dry? Yes, it is just the salt which we are using at home daily. It looks like that salt only, table salt. Okay, so how can we prove it, students, that water is initially present and now no water is there? We can take many salts, students, like Na2CO3 10H2O we have taken. It is washing soda having 10 water molecules, decahydrate, but it is white in color. We cannot able to prove it. Here for the proof I am taking copper sulfate. You have seen in the lab also, students, it is blue in color. This type of color is there of copper sulfate. So copper sulfate, if blue in color, meaning it is having 5H2O. It is pentahydrate. So if I am taking this copper sulfate in a boiling tube, test tube, एक boiling tube में लिया मैंने, boiling वाला test tube जो होता है उसमें लिया, solid form में है ये, without water. It is in the solid form. Its color in the solid form is blue. And as it is heated, we observe on the mouth of the test tube some droplets of water. And some vapors are also seen during this process. That vapors, here we have not taken any water. Then from where this water is coming? That means some water is present in the salt. And that's why you are able to see some droplets of water on the mouth, near the mouth of the test tube. And as the water evaporates, the color of salt becomes white. It was initially what? Blue. And its blue color is now, this is blue in color, and that blue colored salt now becomes white. Okay, students. So this activity proves that if any salt is having water of crystallization, then also it is dry. But on heating, it evaporate out its water of crystallization and becomes anhydrous. So here this copper sulfate which is having 5H2O is called hydrated salt. It is called hydrated salt. Okay, students. And as after evaporation, it is converting into CuSO4 only. No water of crystallization is there. And it becomes anhydrous and color is white. So this activity proves that copper sulfate is having water of crystallization in it if its color is blue. Easily you can identify, students, that blue colored copper sulfate if I am showing, that is hydrated salt having water of crystallization. If I am showing you some white colored salt and I am asking you that whether this copper sulfate is hydrated or anhydrous, if white color is there, that means you will certainly say that is anhydrous copper sulfate. And as you dissolve that copper sulfate, which is white in color, in water, it is again becoming hydrated. So the color obtained will be blue. So this is water of crystallization, and many molecules you will learn later on also, like gypsum, like plaster of Paris. So that we will discuss later in other videos. So for today, this much is there. I will upload some questions also related to this topic, students. Thank you, students.